Hello student, now I am going to discuss, I am continuing from the last class, Boyle's law, pressure volume relationship. Last class I have discussed, just I given a brief idea about the gaseous state and gas laws. Now I am going to discuss Boyle's law, that is pressure volume relationship. On the basis of his experiments, Boyles has done so many experiments. Then on the basis of the experiments, Robert Boyle reached to the conclusion that at constant temperature, the pressure of a fixed amount of the gas, listen here, at constant temperature, T is not changing, T is fixed. The pressure of a fixed amount means number of moles of gas is fixed. That is also not changing. Two things are not changing. Number of moles, that is called a small n, that is fixed. Temperature is fixed. Then how pressure has relation with volume, that he has concluded like that the pressure of a fixed amount of gas varies inversely with its volume. This is known as Boyle's law. Means at constant temperature, the pressure of a fixed amount of a gas varies inversely with its volume. This is known as Boyle's law. Two things are here constant. First, temperature is constant and number of moles is constant, means fixed amount, that is called fixed amount. Number of moles is fixed. Then in that situation, pressure is inversely proportional to volume. This is called Boyle's law. Mathematically, you can write P is proportionality sign, you can give P is inversely proportional to 1 upon V, or P is proportional to 1 upon V. P is proportional to 1 upon V at constant temperature and n, small n. When both are fixed, that time P is proportional to 1 upon V. And when equality sign you will convert, when proportionality sign you will convert to equality, then you have to multiply by some constant K. Then if you will remove the proportionality sign and you want to write equality sign, then you should multiply by K. Then P is equal to K into 1 upon V. Then just do simplification, then you will get PV is equal to K. PV is equal to K, where K is constant. Okay. K is a proportionality constant and its value depends upon the what? Temperature and quantity of gas. What was the fixed, that you have made a fixed quantity of gas and temperature, then this experiment was done. Then this K value depends upon these two things. What was the actually quantity you have fixed? What quantity you have fixed means you have taken, and what was the temperature? At what temperature you have done the experiment? Then this K value depends upon that. Okay, means PV is equal to K. It means that at constant temperature, product of pressure and volume of a fixed amount of gas is constant. If a fixed amount of a gas at constant temperature T occupying volume V at a fixed temperature, at a fixed amount of gas and temperature, at a fixed amount of gas at constant temperature T occupying volume V1, suppose V1, occupying volume V1 at pressure P1 undergoing expansion so that volume becomes what? V2 and the pressure becomes P2, means both are changing. In the beginning, suppose pressure was P1, volume was V1. Now you have changed the pressure, then volume automatically will change. That when temperature is pressure is changing, volume will change. That's why if a fixed amount of gas at a constant temperature T occupying volume V1 at constant pressure P1 undergoes expansion so that volume becomes V2 and pressure becomes P2, then according to the Boyle's law, P1 into V1 is equal to P2 into V2, that is equal to constant. Same way they have followed the what was the PV is equal to K. This is actually, in real sense, this is the Boyle's law. But if change is going on, P1 is becoming P2 and V1 is becoming V2, pressure is changing from P1 to P2 and volume is changing from V1 to V2, then you can write by following the Boyle's law, P1 V1 is equal to P2 V2 and that is equal to constant, because PV is equal to constant K. PV is equal to K is equal to constant. Then you can write on the same basis P1 into V1 is equal to P2 into V2 and that is equal to constant. And after that just you can rearrange, then you will get P1 upon P2 is equal to V2 upon V1. Very simple simplification. P1 V1 is equal to P2 V2, that is equal constant. Then P1 V1 is equal to P2 V2. Then just you simply arrange it. P1 upon P2 is equal to V2 upon V1. Simple, very simple simplification you have done. Very simple things. Now another thing you should know here, that if you will draw the graph between pressure and volume, pressure versus volume, then two graph is possible. One graph pressure versus volume, pressure P in bar you can take and volume you can take in liter or decimeter cube. Then you will draw one type of graph this. At a different temperature you can take for the fixed mass of gas. Then just like a parabolic nature type of graph you will get. Okay. Then one graph you will get this, and second graph you can draw, that is also Boyle's law graph, that is pressure versus volume, but volume now you are taking 1 upon V. Pressure versus volume. Then now this time volume you are taking 1 upon V. Then this time you will get at a different temperature. Suppose 3 temperature you have considered, T1, T2, T3. First time experiment was done at T1 temperature for a fixed mass of gas. Then it was found a straight line. Second experiment was done with another temperature T2 and amount of gas was fixed. That time again you will find a straight line. Third time again, suppose temperature was T3, I have repeated the experiment, and at a fixed mass of gas, that time also you will get a straight line, and all straight line are meeting to the one place. If you draw down, all will meet to the zero origin. Okay, and first graph I told you, same things at a different temperature you will do. Suppose you have done temperature at T1 degree, then that time one, just like a parabolic, you will get these things. How from high pressure volume will when pressure was high, suppose you have done experiment with one temperature T1, then volume pressure, when pressure was high, volume was less. As the pressure is decreasing, volume is increasing. Reverse case. If pressure will increase, volume will decrease. That's why in graph you will find that from high pressure, if pressure is increasing, then volume will start increasing. And slowly as the pressure will decrease, volume will increase, and it will increase just like it will come parallel to the x-axis. Again, second experiment you will do at another temperature, then again same thing will happen, that again you can say as the pressure will decrease, volume will increase, parallel to the first graph. Third temperature also, for a fixed amount of gas, again it will be same way. Pressure will decrease, volume will increase, and it will be parallel with other two. Okay, because temperature, suppose you are changing. First temperature, suppose you have done at 200 Kelvin. Then one graph you will get that pressure, as the pressure is decreasing, volume is increasing. It will come parallel to the x-axis. Then second experiment, suppose you have done at another temperature 400 Kelvin. Then temperature has changed. And the new graph you will get same type of nature will be the same. Pressure is if will decrease the pressure, volume will we will decrease the pressure, volume will increase. Third temperature also same thing will happen. Okay, then two types of graph is possible: pressure versus volume, pressure in bar and volume in decimeter or liter, you can tell. And second graph, pressure versus volume. But here volume will be 1 by B. Then here one term is there, you should understand that the value of K for each curve is different. The value of K for each curve is different because for a given mass of gas, it varies only with temperature. Okay, because you are doing experiment at a different temperature. That's why K value will be different. In the beginning I told you that K value will change only when temperature and fixed mass will change, then K value will change. If both are fixed, you are not changing, then K value will not change. But you are doing experiment at different temperature. That time temperature is changing and mass what you have taken, that is changing. Then that time only K value will change. Okay. Then this you should know the value of K for each curve is different because for a given mass of gas, it varies only with temperature. Each curve corresponds to a different constant temperature and is known as isotherm. When temperature is constant, this question is asked. When temperature is constant, then that time plot is called isotherm. Constant temperature, plot at constant temperature is called isotherm. Okay. Higher curves correspond to higher temperature. Okay. Lower curve represent to lower temperature. And very, very important things I am telling you. Experimentally, it is proved. Experimentally, it is proved. The volume of the gas doubles if pressure is halved. This you keep in mind. It is experimentally proved. It is proved that volume of the gas doubles if pressure is halved, because pressure you have decreased, the volume will increase. Then how much will increase volume? Then by the experiment it is observed that volume of the gas doubles if pressure is halved. So many data is there. Actually, experiment was done with carbon dioxide. That time 0.09 mole of carbon dioxide was taken. At that time temperature was 300 Kelvin. When experiment was done, temperature was 300 Kelvin, means normal temperature only. And number of moles was 0.09. And gas was used carbon dioxide. Then for carbon dioxide, when mass was, means quantity was fixed as a 0.09 mole and temperature was 300 Kelvin, fixed temperature, then that time it was proved that first they proved that volume, if pressure is increasing, volume is decreasing. Many data are there. Few value only I can tell you. Suppose when pressure was 2, when pressure was 2, in the term of 100 Pascal you can tell, then that time volume was 112. When pressure increased 2.5, from 2 to 2.5, then volume decreased 89.2. Again pressure increased 3.5, then again volume decreased 64.2. Again pressure increased 4, then now volume decreased. Again pressure increased, volume decreased. Then actually Boyle's law is like that, both are inversely proportional. If anyone will increase, other will decrease. Inversely, reverse way. Then pressure is increasing, volume is decreasing, like that way. And in this experiment they calculated the K, because P and B volume they were knowing. Then they found the K value. Then K value was almost constant, it was found. Okay, almost constant. Volume by P into V volume was found to be 22.4, 22.30, like that way, 22.47. Then K value, that is the value of P into V. That P into V value depends upon the PV value, at what temperature experiment was done, and what was the amount of gas fixed. Okay, then P into V value, that is called K, that is fixed. Then I have told you about this I told about this PV. Now one relation is there in solving the numericals. That relation is used. That relation is related to density and volume. Then here experiments of Boyle's in a quantitative manner. Experiments of Boyle in quantitative manner prove that gases are highly compressible. I am going to tell about the relation between two, density and volume. I will tell you how. Okay, just listen. Experiments of Boyle's in a quantitative manner prove that gases are highly compressible. Why they are compressible? Then understand, because when a given mass of a gas is compressed, the same number of molecules occupies a smaller space. Same number of molecules occupy a smaller space if you will compress it. This means that gases become denser at high pressure. At high pressure, if you apply more pressure, then all molecules will come closer. Correct? That they will come in a smaller space. This is the important thing. This means that gases become denser at high pressure. A relationship can be obtained between the density and pressure of a gas by using Boyle's law. How? Just listen. By definition, we know density D is related to the mass M and the volume. Density is equal to mass by volume. It is well known. Density is equal to mass by volume. Then now here, if suppose you want to make relationship between pressure and density, then how will you do these things? Then very easy. Density is equal to mass by volume. Then volume V. This V, how will you bring? Then from Boyle's law, PV is equal to K. PV is equal to K. Then V is equal to K upon P. That value we put in this formula. D is equal to mass by volume, V. Then V value you bring from here, Boyle's law, PV is equal to K. Then V is equal to K upon P. That you write here. Then D will become D is equal to M divided by K upon P. And after solving, you will get D is equal to M upon K. M upon D is equal to M upon K and upside P. Then here M and K both are constant. K is already constant, M is also fixed. Fixed means constant. Then a new constant has developed that you can tell K dash, and P is already there. Hence the density is equal to K dash P. If you will remove this K dash, P D is equal to K dash P. Now just if you want to write in the proportionality way, if you want to introduce proportionality, then you have to remove this K. Equality sign you have to remove. Then proportionality sign will come. Then D is directly proportional to P. Then this relationship D is equal to K dash P. This shows that at a constant temperature, pressure is directly proportional to the density of a fixed mass of gas. D is directly proportional to P. This is the relation. This is used in solving the numericals. Okay, then at a constant temperature, pressure is directly proportional to the density of a fixed mass of gas. This I told you relation between D and P. Then today you have learned two things. For Boyle's law, PV is equal to constant, means K. PV is equal to K, and this PV is equal to K you can tell in another way. P1 V1 is equal to P2 V2 is equal to K. And this is the another way to tell. That is the first relation. And second relation, D is equal to K dash P, or you can tell D is directly proportional to P. Then now one in numericals I want to tell you, because in examination numericals will be also asked. Then now you are knowing the concept, easily you can solve the numericals. One interesting numericals I am telling you, which has been actually Charles has done. They were doing experiment. They wanted to fly in atmosphere, in air. They wanted to fly. That's why they were doing experiment, and this is based on that. Then question I am reading: a balloon is filled with hydrogen at room temperature. Just like atmospheric temperature, now suppose temperature will not change very fast. Now suppose morning time, what temperature will be almost constant 1-2 hour. Okay, minor change may be there, but temperature will be almost fixed. Then now question, listen: a balloon is filled with a hydrogen at room temperature. Room temperature means 27 degree. It will burst. They are giving capacity. It will burst if pressure exceeds 0.2 bar. This is the limitation. If balloon will burst if pressure exceeds 0.2 bar. Okay. If at 1 bar, now pressure you have increased. If at 1 bar pressure, if at 1 bar pressure, the gas occupies 2.27 liter volume, up to what volume can be balloon be expanded? Then here three data they have given. One limitation they have given, that if pressure exceeds 0.2 bar, then balloon will burst. Then that is also pressure. Again they have given, if at 1 bar pressure, the gas occupies 2.27 liter. Means they have given that at 1 bar volume is 2.27 liter. Then up to what volume can the balloon be expanded? Means up to 0.2 bar. At 0.2 bar, what will be the volume? That you have to consider, have to calculate. At 0.2 bar, what will be the volume? Means if you will consider P1, 1 bar is P1 and volume is V1, 2.27 liter. Then P1 is equal to 1 bar and V1 is equal to 2.27 liter and P2 is equal to 0.2 bar. Then what is the V2? Then already I told you formula, P1 into V1 is equal to P2 into V2. Correct? This formula you are knowing. By applying this formula, P1 into V1 is equal to P2 into V2. Then P1 is equal to, you can calculate very easily, P1 into V1 is equal to P2 into V2. Then V2 you want to calculate. Then P1 into V1 divided by P2. That is the V2. V2 is equal to P1 into V1 divided by P2. That is equal to V2. according to from the formula. You are knowing formula, and after that you put the value. Then after the putting the value, that is the 1 var, P1 value was 1 var and V1 value was 2.27 liter divided by P2 value was 0.2 bar. Bar will cancel, only liter will remain, just 2.27 divided by 0.2. Then after solving you will get 11.35 liter. Okay, since balloon burst at 0.2 bar pressure, 0.2 bar pressure, this balloon will burst. The volume of balloon should be less than 11.35 liter. You can't fill the gas, hydrogen gas, you can't fill more than below 11.35 liter. You have to fill, because after that balloon will burst. Okay, since balloon bursts at 0.2 bar pressure, then at 0.2 bar pressure, what will be the volume? Then now you calculated V2 is equal to 11.35 liter. Correct? Then you can't fill more than this liter in the balloon. Hydrogen gas you can't fill more than that, otherwise it will burst. Because they have given limitation 0.2 bar. Then at 0.2 bar maximum volume is coming, V2 volume is coming 11.35. Then today now I am stopping only here. Next class I will start Charles' law. Thank you.